So in this video, we're going to talk about how to handle ions in terms of working with Lewis structures when you're working with the number of valence electrons. So in this case, we're going to look at NO2 or NO3, nitrate. So nitrate, NO3 has a -1 charge. So these are going to be approached similar fashion that you approached all the other problems. You're going to start by counting out the valence electrons. So nitrogen's got 5, oxygen's got 6, and we've got 3 of them. But now we have to add the charge. So we have 1 electron, so we're going to add that +1 to get the negative charge. And this will give us a total of 24 valence electrons. Nitrogen's our central atom. We've got 3 oxygens. We're going to draw a bond to each of the periphery oxygens, and we need to subtract out now all the electrons we've lost to bonding. So we've got 3 bonds, 2 electrons. This will give us a total of 18 electrons. Now, we're going to go to the periphery atoms. What we want to do with the periphery atoms is we want to add electrons until we satisfy their octet. Now you might notice there's 3 oxygen atoms, so there's 18 electrons. If we distribute them equally, we're going to get 6. And that's what we need to satisfy the octet. 3 lone pairs on each of the periphery oxygens. And if we go through, every oxygen has satisfied its octet. So now we need to go back to the periphery atom and figure out if it's satisfied its octet. And when we look at nitrogen, we've got 3 bonds, we're beneath the octet. So, like we did for formaldehyde and cyanide, we're going to take one of our oxygen lone pair electrons and kick it down and make a double bond. So this is going to be our Lewis structure now for the nitrate ion. When you are doing ions and you're doing the total valence count, remember, every time you have a negative charge, you're going to add that to the total number of valence electrons. If you have a positive charge, you can subtract it off. So an example of a positive charge would be something like ammonium, NH4. So NH4 plus, nitrogen once again gives us 5 electrons. We have 4 hydrogens with 1. But we have a +1 charge, so we need to subtract off that charge. And this will give us a total of 8 electrons. Nitrogen, 4 periphery hydrogens. Draw our bond to each one. We need to subtract 2 electrons for every bond, so -2 times 4 will give us 0 valence electrons remaining. In this case, this would be our Lewis structure for NH4 +1.